Hello everyone, welcome to the Engineering, Computation and Instrumentation second lab. Today I will talk about an introduction to input and output for basic mathematical computations. Let's start by making a quick revision about the basic structure of C++ programs. Any C++ program must start with a header comment. The header comment tells any person reading the program some basic information about the program, such as the program name, the program author, the date, and what the program does. It is just a comment, as it starts with two forward slashes, as you see here. So the compiler or your computer will ignore it. Every C++ program must have a main function. This is the main function. This main function specifies where program execution starts and ends. So any code between these two curly brackets will be executed. After that, variables must be declared before being used in any other statements in the code. To declare variable, first specify the type of the data the variable will hold. Then specify the name of the variable. After that, write a comment describing this variable. Remember, C++ is a case-sensitive programming language. So temperature here as the name of this variable. Temperature with small t is different from temperature with capital letter T. So as style convention, we use all lowercase letters for variables names, as what we did here. We use all lowercase letters for variables names, and we use all uppercase letters for names of constants. So here by is constant, so we define the name of y with using all uppercase letters. Remember, don't forget this. All C++ statements must end with semicolon. After finishing writing all of your program statements, we write return 0 to end the main function. So return 0 will tell your operating system that the program is terminated normally. Don't forget to write the closing curly bracket to end or to close the main function. Now I will talk about how we can input or output data in C++. Let's start with the cout object. Cout is an object used together with the insertion operator, as you see here, to output or print text on the screen. When using cout, you must include the input-output stream preprocessor directive at the top of your code. So if you are going to use the cout object, you must write at the top of your code #include input-output stream. The #include input-output stream is a header file library that let us work with the input and the output objects. Now, here is an example about C++ program that print hello world on the screen. Let's state the function of each line in this program. As we want to print hello world on the screen, so we will use the cout object. So we must start our code with the preprocessor directive #include input-output stream that enable us to work with the cout function. In the second line, we have using namespace std, which means that we can use names for objects and variables from the standard library. In the third line, we have the main function, which specifies where program execution starts and ends. Any code between these two curly brackets will be executed. In the fourth line, we have the cout object with the insertion operator to print hello world in the screen. Remember, don't forget the semicolon at the end of each statement in the code. Finally, we have return 0 that terminates our program. So the result of our code will be printed on our screen, hello world. We can use manipulators for output formatting. To set cout to fixed precision, we use cout fixed. To control precision, we use set precision of n, which sets the number of decimal digits to the integer n. Let's understand what do fixed and set precision mean throughout the following example. We want to print the value of 1/3 by setting the precision of the result at 1 time to 2 decimal digits only after the dot, and on the other time to 4 decimal digits only. So we start at first by writing Cout fixed set precision 2. This will control the precision of our output to 2 decimal digits after the dot. After that, we write Cout 1/3 equals, and we write 1 divided by 3, then end line. The end line here will make the next output go to the next line. So the computer will print the value of 1/3 to equal 0.33 as we set precision to equal to 2. After that, we want to set the precision to be equal 4. So we will write Cout precision of 4. This will control the precision to 4 decimal digits. After that, we write Cout 1/3 equals and write 1 divided by 3, then end line. So the computer will print the value of 1/3 to equal 0.3333 as we set precision to 4. In order to be able to use the fixed and the set precision objects, we need the preprocessor director #include input-output manipulator. So remember, if we want to output something, we need to use the preprocessor director input-output stream. And if we want to format this output, we use input-output manipulator. So #include input-output stream will enable us to deal with the Cout object, and #include input-output manipulator will enable us to use fixed and set precision objects. As you see here, the fixed object and the set precision object are associated together. So if I need to control the precision of an output, I must write Cout fixed and then define the value of the set precision. But here I write set precision directly without using fixed. So this is a general note for you. As long as you use the fixed object in your code one time, you don't need to use it again. Now let's talk about numerical input with Cn object. We use Cn object to read data from your keyboard. Cn object, as I told you, we use the preprocessor directive #include input-output stream to enable us to work with the input and the output objects. And we have here Cn as input object. So in order to be able to use Cn, we need to use the preprocessor directive #include input-output stream. So by using the Cn object, you are asking the user to enter through the keyboard the value of a predefined variable. So don't forget to declare the type of this variable at first. Here we are asking the user to enter the values of predefined variable 1 and variable 2. Cn execution is complete when user hits the enter key after the required number of values have been entered. Let's understand the operation of Cn object through this example. We want to write C++ program that takes from the user the values of the length and width of something and print on the screen their values. So as we want to ask the user to enter, so we will use Cn object, and we will ask the user to print, so we will use the Cout object. So we need at the first line of our code to use the input-output stream preprocessor directive. So we write #include input-output stream. In the second line, we have using namespace std. As I told you, we using this command. That means that we are allowed to use names for objects and variables. After that, I must use the main function to specify the start and the end of our code, as you see here, between the two curly brackets. And after that, I must declare my variables. Here I have two variables. I have double length and I have double width. So after that, I want to ask the user to enter the values of the length and width. So I must print a message or sentence to the user to ask him to enter the values of the length and width. So I will use to print, I will use the cout object. So I will write cout, enter the length and width in centimeter. So this what will be on the screen for the user. So your code will ask the user to enter the length and width in centimeter. In order to make the user able to enter the values of the length and width, I must use the cn object. So I use cn length and width. What will the user do? The user will write, for example, as here, 10 space 20 and then enter. So 10 will be the value of the length space 20 is the value of the width, and after the user press enter, the then execution will be complete. So after that, we want to print the values of the length and the width on the screen. So we will use to print the cout object. So we will use cout. You entered here, your program will print the value of length, which is 10, and the value of width, which is 20. And after that, we use return 0 to terminate our program. Don't forget again, use the use of semicolon at the end of each statement. Now we will define the math functions. We use math functions as sometimes we need to use some functions such as the sine function, the cosine function, the absolute. So in order to be able to use these mathematical functions, we must use the preprocessor directive cmath. So in order to be able to use sine function, cosine function, absolute function, for example, I must to use the preprocessor directive #include cmath. For example, here I have a predefined variable b, which is equal sine theta. Sine theta, we can use sine theta, which is math function. So in order to be able to use it, we must use the #include cmath. So sine is predefined function in cmath library, which returns the value of the sine of the angle. As you know here, so after we using the sine theta, this will calculate the sine of the angle, and this will return to be the value of our variable b. Okay, so we will need these functions and we will need this preprocessor directive in our lab too, as during your lab exercise you will need to calculate the absolute value of one variable. So in order to be able to use the absolute function, you must write #include cmath at the top of your code. Also, you will use the sine function, and also you will use the arccosine or the inverse cosine in your lab exercise. Now I will introduce what is required from you in lab 2 exercise. Using this starter code, you are required to write a C++ program that asks the user to enter and then read in the values of an angle of attack and corresponding measured lift coefficient. So at first, you have to define or declare the variable which is angle of attack, and declare another variable, the measured lift coefficient. And in order to be able to ask the user to enter the values, so you must use the cout object, and in order to make the user able to enter the values of the angle of attack and the corresponding measured lift coefficient, you must use the cn object. And as you know, in order to be able to use the cn object and the cout object, you must use the preprocessor directive #include input output stream at the top of your code. After that, you are required to compute the modeled lift coefficient for the entered angle of attack using this expression. So you have at first to define or declare the new variable here, c. C is defined using this equation. Here in this equation, we are using the sine function. And as you know, in order to be able to use the sine function, we must use the preprocessor directive #include cmath at the top of your code. And here in this equation, you are given the value of A and the value of B, and alpha, the user will enter its value, and we need to define the constant by. For sure, you know how to define or declare a constant by, but here in this code, we need from you to use constant for by using the arc-cosine function. So you need from you to define by in terms of arc-cosine function. As you know, what is the value of cosine by? Cosine by is equal to -1. So by is equal to inverse cosine of -1 or arc cosine of -1. So in order to be able to use the arc cosine function, we must use the hash include CMAS preprocessor directive at the top of your code. After that, you are required to do some computations where you will use the absolute function, which is a function, predefined function in the CMS preprocessor directive. And after that, you are required to output. Output means C out. The angle of attack, no decimal places. No decimal places. That means that we will set precision to 0. And the measured lift coefficient with 4 decimal places. 4 decimal places means that we will set the precision to 4. And the modeled lift coefficient 4 decimal places. Set precision to 4. And the lift coefficient percent difference 2 decimal places, that you will set the set precision to 2. You are given here starter code to the set precision. And as you know, in order to be able to use the fixed and the set precision objects, you must to use the preprocessor directive hash include input output manipulator at the top of your code. I hope everything is clear for you now. Thank you.